Right, simplifying radicals again. Seriously, was what we're doing. So today we're literally just going to simplify radicals. And the reason why we're practicing this is, guess where some of you have struggled a little bit this year? Simplifying radicals. We got to be good at it, okay? It's one of those things that you have to be really good at. Is one reason why we're reviewing lines, equations, lines, you got to be really good at equations and lines. We're going to be reviewing simplifying radicals because you're going to be doing different types of radicals, like cubic roots, third roots, fourth roots, all that type of stuff. But you have to be able to do them quickly in your head and being able to do them to your best ability and not hesitate. You also have to factor really well. That's just another skill that never ever goes away. I got a student just talk to me that's in like pre-calculus and algebra 2, and they said they're so tired of the teacher saying, okay, now let's factor. Because that's basically, they do something and then they go back to factoring every single time and use that in factoring. So that type of stuff is used over and over again. So let's see what you remember. I'm just going to go and practice with you guys problems because you should remember the basic idea of simplifying. One thing you do need to remember first, though, remember that even exponents are perfect square numbers. So remember, for instance, if I have x to the fourth times x to the fourth, that gives me x to the what? X to the 8th, because remember, I add them together. Also remember, if you had something like this, y to, let's say y cubed times y cubed is y to the what? Y to the 6. So remember, even numbered exponents are perfect square numbers. So it's very easy to take the square root of an even numbered one. However, we need to remember that you're sometimes going to be given odd number exponents, like x to the 9th. But because we know that we can add exponents together when we're multiplying the same bases like that, we can actually use that to simplify radicals better. Because remember, we can rewrite x to the 9th as x to the 8th times x to the what? First. Now, is x to the 8th a perfect square number? Yes. Because x to the 4th times x to the 4th is x to the 8th. So that's one of those things you need to remember really well. What if I wanted to change y to the 5th? And I need to factor into, I have a perfect square number. What would I factor that into? Y to the 4th times what? Yeah, y to the 1st. So we're going to use those in order to simplify well. So you're going to have radicals like crazy in your square roots anymore, because that's basically what you're going to be working with on there. All right, so let's look at the first one. Let's just practice. So, and really look at the directions. Simplify. Remember, we talk about simplify means get in simplest form. And a lot of times we'll say in simplest radical form when we're working with it. So let's try this one. Square root of 75, x to the 8th, y to the 5th. So square root of 75, x to the 8th, y to the 5th. Now remember, there's a couple different ways you can do it. Some people are prime factorization people. That's the only way they can do square roots. The problem is you'll get very large numbers. So what do we do first? Well, remember that we divide it into our perfect square number factors, and then we do the ones that aren't perfect square number factors. On the left is where we put our perfect square. Guys, what's the largest perfect square that comes out of 75? So we have 25. And then we get left with 3 on the right. And then I have x to the 8th. Is that a perfect square number? All right, so x to the 8th gets put in on the left. Then I have y to the 5th. Y to the 5th. Oh, look at that number on purpose I picked up above. We know it's not a perfect square number, but can I factor a perfect square number out of y to the 5th? What do we get? Y to the 4th, and then you're left with y. Then you just take the square root of these. Guys, what's the square root of 25? So we have 5. What's the square root of x to the 8th? X to the 4th. Square root of y to the 4th? Y squared. Remember, even exponents are so easy. You just have to divide them by 2. And you're going to get times the square root of 3y. That would be your answer. What do you guys think? Remember? And it's just one of those skills that takes a little bit of time. What if I had a number out in front of the square root of 75? What if I had something like 3y or something like that? What would I do with these numbers then? Wouldn't you multiply it to the 3y? So just remember, don't forget your rules. Okay, don't forget your rules. All right, let's try another one. A few of you guys are still struggling with this a little bit too. What if I had something like this? Simplify the square root of 27 over 16. What would you do? Yeah, a lot of times one strategy is to rewrite them. Literally write as the square root of 27 over the square root of 16. Because when you do that, what's the first thing that people recognize right away? Square root of 16 is what? So we see this right away then when we split it. Then you just keep asking yourself, all right, how do I make this in simplest radical form? Can I simplify the numerator more? Can we, guys? Yeah, we totally can. You can take out a square root of 9. And then you should get 3 root 3 over 4. Now, if you're able to, this is where the point we want to get you to. If you're able to go from here to here, we like that, okay? Teachers appreciate that because we're not wasting the time of having to do it right every little step down. It's because we need you to be able to do radicals efficiently, kind of like multiplying division anymore. We need you to be that good when you're working with radicals as well, especially so we can proceed quicker with higher level problems. So again, if you don't show me every little step here, just make sure you're going to get it right, but also make sure you show the essentials as well. Now, before you're done, you should always check something. And this one's in simplest form, but you should always check, oh, can I simplify those numbers at all? And the answer is no, not this time. Then you're like, okay, then you should feel confident that you're done. You should feel very confident that you're done. What do you guys think so far? Good remember wins? Some of you are like, oh, I've never been good at this. Doesn't mean you can't do it. All right, you just have to get better. You have to dive into it. All right, here's another one. How about simplify this problem for me? 2 divided by the square root of 8y. Divided by the square root of 8y. What would you guys do? There's a couple different approaches to this, and both to me are really good ways of doing it. Start talking to me. Some of you already got it done. What should I do first? Someone take the square root first. So you got 2 over 2 root 2y. All right, that's not a bad idea. Can I simplify anything with that? Yeah, can I go ahead and go 1 over then the square root of 2y? Am I done? No, exactly, because we can't have a radical in the denominator of the fraction. Very good. So we have to use that thing. It's called rationalize the denominator. So when you have to rationalize your denominator, remember you have to multiply by that square root. So I got the square root in the denominator. I also have to then multiply in the numerator because remember I need to multiply by 1. So square root of 2y over 2y. Now, did anyone see how to do that one differently? Let me show you another way that works. So using the same thing. I got 2 times the square root of 8y. All right, another way, if you are really quick at seeing this is not a rough way of doing it at all, is to not worry about multiplying by the radical times itself. You multiply the radical by another radical that makes perfect square numbers. So for instance, what if I multiplied the denominator by root 2y? Look what happens. The numerator becomes 2 root 2y. The denominator becomes the square root of 16y squared. Can I simplify the square root of 16y squared? So I get 2 root 2y over 4y. Oh, look. Can I simplify these real quick? Do you notice it's just another way of doing it? There's no, if you had Mr. McDonald last year, he showed you that method. He did show you that method. I kind of prefer either simplifying first and then simplifying the radical, or just right away you could have also gone, oh, there's a radical in the denominator. You could have also just multiplied by root 8y. The process is going to be a little bit different, but would you get the same answer? Yes, but you have to be able to rationalize your denominators when you're working with that. All right, let's keep going. Because the only time, we don't just do it now, like we need to make sure that we're able to simplify other types. So let's keep simplifying. So same direction, simplify. What if you had a problem like this? The square root of 125 minus 3 root 5. What do you guys have to do? Can I add and subtract those right now in the way that they are? No. Again, what's the rule? Always do what with your radical? Always simplify your radical. So if I always simplify my radical, what can come out of 125? 25, what's the square root of 25? So it's 5 root 5 minus 3 root 5. Now, if and only if they're in simplest form and my radicals are the same thing underneath the radical sign, so the number is the same, okay? Then I can add the numbers out front, my coefficients out front. So you'll end up getting 2 root 5. Quick question, what if I had something like this? Can I combine those two? But is it in simplest form? So that would be in simplest form at that point. So remember that it has to have the same radical sign. It has to be the simplest radical form, and they have to be the same. All right, let's try another one. A little more fun. All right, so the square root of 200 minus 5 root 75. See if you guys can do it real quick. Did you guys get 10 root 2 minus 25 root 3? Can I simplify it more? Nope, that's your final answer. All right, another one. Very helpful when we're working with it. What if I had this problem? 3 times the square root of 3 times 4 root 5. I'm multiplying two radicals together. How do I do it? Anyone remember? Yes. Mm-hmm. Yeah. It's kind of like if you're multiplying variables together, right? So if I was multiplying something like 3x times 2y, what do we do first? We multiply the what? The 3 and the 2 together first. So my question to you is, why would I change that process now? So I still have two values. They're both constants. They're out front. Multiply them together. What's 3 times 4, guys? 12. But then you need to make sure that you multiply the radical together. So you get the square root of, well, what's 3 times 5? 15. Always ask yourself, is that in simplest form? Is the square root of 15, guys, in simplest form? Yeah. So then you're done. Be careful, but make sure you remember how to work with those. All right, memories. Are we being jarred a little bit more? Memories. All right, good. Let's make sure we have this one. All right, now I'm going to actually give you a little bit harder problem that a few of you might not remember how to do, but some of you might rock this. All right, so this was probably done at the end of last year for most of you in math class, but here's the question. I want you to simplify this. 5 over the square root of 7 minus the square root of 2. What's my dilemma on this one? Do I have a dilemma at all? Okay, I'm a radical denominator, and I don't have just one, I have 2. And unfortunately, they're not being multiplied together, they're being what? Subtracted. So we're going to use the idea of actual foiling to help us out. We're going to use what's called multiplying by the conjugate binomial. So what we're going to do is we're going to take and realize in order to rationalize the denominator, I'm going to actually have to use a binomial this time. And I'm going to use what's called the conjugate binomial. And a conjugate binomial is a binomial that's exactly the same as another one except for one thing, the sign between the two values. So instead of having a minus sign, guess what I'm going to have there? I'm going to have an addition sign right there. And then the top I'm going to have a square root of 7 plus the square root of 2. Because remember, all my whole goals when I'm rationalizing the denominator is to multiply my fraction by 1 so I'm not changing its value. Am I still multiplying that whole thing by 1? All right, now off to the side, let's multiply this and see what we're going to get. Actually, yeah, let's do it here. The square root of 7 minus root 2 times, let's go square root of 7 plus root 2. All right, let's do it together. Guys, what's the square root of 7 times the square root of 7? That's going to be 7, right? Because that's the square root of 49, which is 7. Great. Then we do our outside. Square root of 7 times a positive root 2. So I get positive square root of 14. And then we go our negative root 2 times 7. So that's going to be a negative root 14. What if I have a negative 2 times a negative root 2? What do we get here? Minus what? Minus 2. What happened to my radical 14s? So I get 7 minus 2, which is 5. Now, let's just pause for a moment. You guys don't write anything down except for the fact that's 5, okay? Here's the deal. This is why I can't do like what we've done for all of our other problems. Because what if I decided to go, all right, root 17 minus, I mean, not root 17, square root of 7 minus root 2 times the square root of 7 minus root 2, because all the other problems that we just did when we rationalized denominators before, we just multiplied by the denominator, right? So if I just multiplied by the denominator, shouldn't it be the same thing? Well, the answer is no, because again, it's all about the FOILing. So if I did root 7 times root 7, I'd get 7 again, because that's the square root of 49. This time I would get a root 7 times a negative root 2, that'd be a negative root 14. A negative root 2 times root 7, that's a negative root 14 again. A negative root 2 times a negative root 2, that'd be a positive 2. I'd end up getting 9 minus 2 root 14. Did I get rid of a radical when I did that? Because remember, I'm trying to rationalize it so there's no radicals in the denominator. So I can't use the same sign. So that's why we use the conjugates. So then what does that keep simplifying down to? Well, people who recognize the patterns real quickly literally can go from here to here in like a heartbeat. A lot of you, what I'd encourage you, show more work than that, please, just until you feel a little more confident. But look at your numerator. I just have to distribute this twice. I get 5 root 7 plus 5 root 2 all over. What did we get that to be when we multiplied root 7 minus root 2 times root 7 plus root 2? We got it to be what? 5? Are we done? No. Can 5 divide into both terms in the numerator? Then you can simplify. You can even rewrite it like this if you wanted to. But my final answer is just going to be root 7 plus root 2. That's in simplest form. Like I said, a lot of people maybe need to write it down, maybe write this step down if they need to. Just be very careful. It's very easy to lose track of signs and stuff when you're working with that. All right, did you guys remember working with those conjugate binomials last year? Nope, it was last year. All right, it was the end of the year last year. You really learned how to do stuff like that. So it's very easy to forget. So should we do one more? Do you guys feel pretty good? You guys want to just do homework right now? All right, well, that's what homework is. Simplifying radicals and more equations of lines. And maybe circles thrown in there because that's a good review anyway. You guys good with that? All right, excellent.